Hello, welcome friends. Me Anila. The topic of my discussion is about lactic acid fermentation. But before this, don't forget to like and subscribe my channel and press bell icon. Friends, in this video, I will tell you about lactic acid fermentation and numericals related to lactic acid fermentation. First of all, I would like to tell you that there are in respiration, which is conversion of sugar in the presence or absence of oxygen to form certain organic compounds, is called respiration. There are two types of respiration: aerobic respiration, anaerobic respiration. Anaerobic respiration is also called fermentation. Aerobic respiration occurs in the presence of oxygen. Glucose in the presence of oxygen is converted to carbon dioxide and water. On the other hand, in anaerobic respiration, which is also called as fermentation, it occurs in the limited supply of oxygen or scarcity of oxygen. There are two types of anaerobic respiration: ethanolic respiration and lactic acid respiration. In ethanolic fermentation, products are ethanol, carbon dioxide, and energy. In lactic acid fermentation, the products are lactic acid and energy. There are two types of lactic acid fermentation: homolactic fermentation, heterolactic fermentation. In homolactic fermentation, occurs in yogurt where lactose is converted to lactic acid. Heterolactic fermentation occurs when lactic acid, ethanol, and carbon dioxide are produced. It occurs in pickles. In this video, I will tell you about homolactic fermentation and numericals associated with it. Now, this is the equation for homolactic fermentation. Glucose is converted into two molecules of lactic acid plus 2 ATP, that is energy molecule, adenosine triphosphate consisting of adenine base, ribose sugar and phosphate groups. Lactic acid is a 3-carbon compound with a carboxylic group. C6H12O6 glucose is converted to two molecules of C3H6O3, two molecules of lactic acid plus 2 ATP. In aerobic respiration, 36 to 38 ATP are produced, while in fermentation, 2 ATP are produced. Example number 1. If 20 gram glucose undergoes homolactic fermentation, how many grams of lactic acid are produced and how many moles of ATP are generated? So, by the help of the above equation, we can solve this numerical. Mass of glucose is given. It is homolactic, means only lactic acid and ATP is produced. We have to find mass of lactic acid and moles of ATP that are generated. Solution. First we will calculate moles of glucose, that is 20 gram already given in the example, divided by 180 gram per mole, which is the molecular weight of glucose. After solving, moles of glucose is calculated to be 0.111 moles. Since 1 mole glucose produces 2 moles lactic acid, as we have seen in the equation, so 0.111 moles glucose produces 0.222 moles lactic acid. We will multiply 0.111 with 2 and divide by 1. We get 0.222 moles lactic acid. Moles of lactic acid are calculated. Now we will calculate mass of lactic acid. Lactic acid mass is equal to moles, 0.222 moles into 90 gram per mole is the molecular weight of lactic acid. After solving, mass of lactic acid is calculated to be 19.98 grams. So we have calculated mass of lactic acid. Now we have to calculate moles of ATP. Since 1 mole glucose produces 2 moles ATP as we have seen in the example, so triple one moles glucose produces 0.222 moles ATP. Moles of ATP are calculated. Now we will apply the formula. Number of molecules is equal to moles into Avogadro number. Moles, we will write moles of ATP 0.222 moles into, this is the constant Avogadro number 6.02 exponent 23. After multiplying, the number of molecules of ATP are calculated to be 1.336 exponent 23 molecules of ATP. So we have calculated mass of lactic acid and number of molecules of ATP. Example number 2. A 100-liter fermenter is charged with a glucose solution at 80 gram per liter. 92% glucose is converted to lactic acid by homolactic acid fermentation. So we have 100-liter fermenter. The glucose solution is concentration is 80 gram per liter. Initial glucose, its 92% is converted to lactic acid by homolactic fermentation. Now, part A. We have to calculate total mass of glucose initially and mass converted to lactic acid. Since 1 liter has 80 gram glucose, so 100 liter has 8000 gram glucose. So this 8000 gram glucose is the total mass of glucose initially. Mass of glucose converted to lactic acid is equal to, we will write initial mass 8000 gram multiplied 92%, that is given, divided by 100 because it is in percentage. After solving, mass of glucose converted is equal to 7360 grams. Now we have to calculate moles of glucose consumed and moles and mass of lactic acid produced. First, moles of glucose, we will write amount 7360 gram divided by 180 gram per mole, that is molecular weight of glucose. After solving, moles of glucose is calculated to be 40.888 moles. Now we have calculated moles of glucose. Now we have to calculate moles and mass of lactic acid produced. 1 mole glucose produces 2 moles lactic acid. So 40.888 moles glucose produces. We will multiply it by 2 and divide by 1. We get 81.776 moles lactic acid. We have calculated moles of glucose, moles of lactic acid. Now we will calculate mass of lactic acid produced. Mass of lactic acid, we will write moles 81.77776 moles into 90 gram per mole is the molecular weight of lactic acid. After solving, mass of lactic acid is calculated to be 7359.84 grams. We have calculated mass of lactic acid. Part C. We have to calculate moles of ATP produced. Since 1 mole glucose produces 2 moles ATP, so 40.888 moles glucose produces. We will multiply it by 2 and divide by 1. We get 81.776 moles ATP. Now moles of ATP are calculated. Part D. Lactic acid concentration in gram per liter at the end of fermentation. Because the fermenter volume is 100 liters and we have to find lactic acid concentration in gram per liter. 100 liter contains 7359.84 gram lactic acid. So 1 liter contains 73.5984 grams. So the concentration of lactic acid at the end of fermentation is 73.5984 gram per liter. Part E. Number of lactic acid molecules produced. We will apply the formula number of molecules is equal to moles into Avogadro number. We will write moles of lactic acid 81.776 moles into Avogadro number 6.02 exponent 23. After solving, number of lactic acid molecules are calculated to be 4.922 exponent 25 molecules. So we have calculated number of lactic acid molecules. In this way we can ferment sugars. So in this way we can calculate different quantities in lactic acid fermentation. Friends, if you have any question you can ask me on comments. I can help you. Thanks.